Good evening, everyone. Welcome to Unacademy. Welcome to the session. So I hope I'm audible to you guys. So sorry for the slight delay in the session. So let's start the session of the digital circuits. Today onwards, we are going to start the main part of the digital circuit. So this is the title of this course: Learn Digital in 20 Hours. Okay. So if you want to learn digital in just 20 hours, here is the course for you guys. And today we are going to start with the first chapter: Combinational Circuits. Ready? Chalo. Just a moment. Okay. So let's start the session. Before that, ये सभी yesterday class का notes है ये today's session. So now it is combinational circuits. Okay, अभी तो Unacademy पे offer चल रहा है. कल तो last day है to get the offer, and here is the offer for you. You will be getting what is that, maximum up to 30% you can save on an Academy subscription if you take the subscription of 1 year, 15 months, or 18, 30 months. You will be getting 2 months for free, absolutely. And these are our toppers this year from electrical and EC in the ESE examination. And the new batch is going to start on January 18th. I'm going to start the new subject, Signals and Systems, at 7 a.m. for 2024 and 2025 aspirants. So if you are aiming for GATE and ESC 24-25, you can join this batch and continue your preparation. So let's start this. In this batch, definitely you will be getting top educator का classes मिलेगा, and also live exams मिलेगा. पूरा syllabus comprehensive way पे cover हो पाएगा. This is what we call 2024 और 2025 batch के लिए course. So let's start. So मैं तो already बताया, ये part तो हो गया. So this is what we are going to start today. So मैं तो plan किया पूरा syllabus coverage कैसा करना. So इसमें मैंने ऐसा plan किया 6 घंटे लेना चाहिए मैंने. 6 hours for combinational circuits, 8 hours for sequential circuits, and another 6 hours for data converters. Altogether, I can finish your syllabus in 20 hours. Okay, this is what we are planning. So now we are entering into the combinational circuits. So these are the things yesterday I have given you. So in combinational circuits, I can classify or divide your syllabus into two parts: arithmetic circuits and switching circuits. So इसके लिए 3 दिन लगेगा ये combination chapter के लिए. So आज तो मैं 2 घंटा ले रहा हूँ. Maybe tomorrow I will take 2 more hours and I will finish the syllabus. So guys, generally I'm trying to take the session by 8:30. Sometimes due to some reasons I'm not able to start the session on time. So sometimes it may start at 9, but whenever it starts, it will be generally 2 hours of the duration. So if I start at 8:30, I'll complete by 10:30, but it will not be delayed, beyond 9. So मेरा प्लान तो ये है आज अर्थमेटिक सर्क्यूट्स को खत्म करना. लेट्स सी. ओके, चलो. अर्थमेटिक सर्क्यूट्स में आपको क्या होता है सर, क्या मिलते हैं सर, क्या डिस्कस करना चाहिए, व्हाट वी आर गोइंग टू डिस्कस इन द अर्थमेटिक सर्क्यूट्स. मैं तो ऑलरेडी लास्ट मिनट रिवीजन के लिए ऑलरेडी पीडीएफ शेयर किया मेरा टेलीग्राम चैनल पे, शॉर्ट नोट्स ऑफ द डिजिटल सर्क्यूट्स, राइट. ये वाला चैप्टर होने के बाद आई कैन शेयर द नोट्स. डेली बेसिस में आई कैन नॉट शेयर इट. ओके. So after completion of the chapter, I will share it. Don't worry. Okay. But don't rely on these notes. Why I'm saying is sometimes in this system there is an error. After the class, while saving, if something wrong happens, the entire data is gone. That's why for some classes I am not able to share the notes. Okay, but I'll try to give you, don't worry. In the worst case, I'll give you my comprehensive notes also, no problem. So let's start. So arithmetic circuits का मतलब क्या है सर? Arithmetic operations करना चाहिए हमारा कंप्यूटर में. So जैसा आप दो नंबर लेके ऐड करना चाहिए, you want to take two numbers and add it in the computer or subtract in the computer, multiply in the computer. You can do a number of operations, but in our syllabus, what we are discussing is the basic operations with the arithmetic circuits like adder, subtractor, and multiplier. So using the digital circuits or digital gates available, how to design this arithmetic circuits, this is what we are going to discuss. And different type of designs available, which design is having what particular advantage and disadvantage, all these things we are going to discuss in this particular case. So ready? चलो. So before going further, if you have studied number system, I did not give you the basic, but आप लोग तो number systems नहीं पढ़ा, so इसलिए मैं थोड़ा सा basic तो देना चाहिए. So let me give you some basic of the addition and subtraction. सर ये सब हमारे को पता है, इसे addition subtraction में discuss करने के लिए क्या नहीं, बाइनरी पे addition subtraction आपको पता नहीं ना, ये explain तो करना चाहिए. So basics of binary addition and subtraction. ठीक है भाई, बाइनरी एडिशन और सब्ट्रैक्शन का बेसिक. So now listen here. If you add two numbers, here I am speaking about arithmetic addition. 0 plus 0, answer is 0. 0 plus 1, your answer is 1. 1 plus 0, answer is 1. Here plus is not OR operation, it is arithmetic addition. What is 1 plus 1? Arithmetic addition pair. If you add 1 and 1, what you will be getting it is 2. Okay. So 2 in the binary, whenever it is possible, always feel free to comment your answer because it will make you involved in the class. जैसा आप लोग पैसिवली बैठ के क्लास देखेंगे तो पसंद नहीं होता है. मैं आप लोग क्या करना, कभी भी टाइम पे आपको पॉसिबिलिटी है तो व्हेन आई आस्क ए क्वेश्चन, व्हेन आई एम एक्सप्लेनिंग समथिंग, आप लोग तो कीप ऑन कमेंटिंग. इट आल्सो मेक्स यू पीपल टू बी एक्टिव इन द क्लास. ठीक है. सो 1 प्लस 1 आपका आंसर क्या है सर? 2 सर. 1 प्लस 1 का आंसर क्या है सर? 2. बाइनरी पे 2 को कैसा रिप्रेजेंट करना सर? 1 प्लस 1 is 2. 2 in the binary is represented as 1 0. Okay sir. In this 1 0, this is called sum and this is called carry. What is the name? Technical name, sum and carry. So here, what is the carry you will be getting? It is 0. Okay, sir, no problem. So this is the first basic of the addition. So let's discuss a circuit which can do this job. Let's discuss a circuit which can do this job. So let me make this circuit. The first one which can do this job is called half adder. Okay. You have two numbers which are nothing but bits A and B. So the AB can be 0 0, 0 1, 1 0, 1 1. When you do addition of this, you will be getting the result which contains a sum and a carry. So what is the sum? You will be getting 0 plus 0 is 0, 1 1, no carry, no carry, no carry. 1 plus 1 is 2, which is 1 0. You should read in this way. Sum and carry. Okay. So if you write the expression of sum, it is nothing but a bar b plus a b bar. This expression will give you a XOR b. How to write this expression, sir? It is equal to 1 in the first middle two case, a bar b plus a b bar. Similarly, what is your carry? It is a into b. So you can simply represent or implement this by a and b. If you take a and b, if you give it to an exclusive OR gate, you get sum. If you give it to an AND gate, you get a carry, right? So that is about your sum and carry. Okay, so that will finish your half adder. Okay, so why it is called half adder, we will discuss it definitely. Okay, let's move little further. Now, in the practical case, when you do the addition, suppose you have a number. Mm, yeah. In the normal addition, ले लो यार. Okay, two. You have a number 2345. 2167. I want to add these numbers. What is the normal addition? Basic addition में क्या होता है सर? 5 plus 7 कितना होता है सर? 12. 5 plus 7 is 12. 1 plus 4 plus 6 11. 1 plus 0 plus 3 11 का मतलब है ना. 1 plus 3 plus 1 5 and no carry and 4. Right. You can understand here. Listen carefully. So when you add these 5 plus 7, 12, 1 plus 4 plus 6, 11, 1 plus 3 plus 1, 5, and 0, 2 plus 2, 4. Okay, so please understand why I am discussing this much basic addition is whenever you do addition, the result contains sum and carry. The carry should be given here. So in a practical adder circuit, there is a need. You should add three numbers at a time. You should add three numbers at a time. What are they, sir? The two numbers originally and the bit, the digit which is coming from the addition of these two. Okay? So the addition of the previous will give you carry to the next stage. So now you take in the binary example. In the binary, 1 plus 1 0 1 1 double 1. Okay, 1 0 1 नहीं है तो ये ले लो 0 to 2. Now 1 plus 1 sum 0 carry 1. That carry is to be given to the next state. How addition is to be done in the binary, I'm explaining. Then we design a circuit which can do this job. So now 1 plus 1 plus 1. What is 1 plus 1 plus 1, sir? 3 ones. So 3, sir. 3 in the binary. 3 in the binary is 1 1, sir. So you should take 1 as the sum and 1 as the carry. And here 1 sum 1 plus 0 plus 1 is sum 0 carry 1. 1 plus 1 sum 0 carry 1. So this is your result. Okay, this is the entire result. Okay, so this is how you should add three digits. That is, so in practical case, you should add 3 bits at a time. That's why this is called as half adder only. Why? Because it is adding only 2 bits at a time. Now let's have a design of the circuit which can do addition of 3 bits at a time. So let's discuss that. That is called as full adder. Okay, so please see full adder. You have now 3 bits. The third bit is the addition coming or the bit coming from the carry of the previous addition. That is what we call carry input. And you have the result which contains a sum and carry. Okay. Now listen. Yeah. If you have 3 bits, you have 8 possible combinations. Okay. Now if you add them, what is the sum? What is the carry? All zeros will give you two zeros. All zeros 1, 1. 1 plus 1, sum 0, carry 1. 1. 1 plus 1, sum 0, carry 1. 1 plus 1, sum 0, carry 1. 1 plus 1 plus 1 is 3. 3 means sum 1, carry 1. Okay? Sum 1 and carry 1. So this is your sum and carry. Now what is your sum is given by, it is a sum of the min terms. What are the min terms? It is giving you 1 in the output expression is 1, 2, 4, 7. And this, let me solve by K-map. Okay, now listen. So sum of the min terms 1, 2, 4, 7, because when the input is 1, 2, 4, 7, you are getting output is equal to 1. So sum of the min terms 1, 2, 4, 7. This is not a minimizable function. This is a standard function of A XOR B XOR C. How to identify XOR gates, sir? Here there is no minimization possible. One point. Second point is when input contains odd number of ones, output is equal to 1. How many ones are present in 111? 3 ones. 3 means odd. How many ones are present in 001? Only 1 odd. So this output is in the form of when input contains odd number of ones, output is equal to 1. This function is called as exclusive OR gate. That is, I am speaking about sum. So let's do the same thing for the carry also. So now for the carry is equal to sum of the min terms. Sum of the min terms, what are they? 3, 5, 6, 7. Sum of the min terms 3, 5, 6, 7. So you can make a pair. Yesterday class I have given this example already, and you can make a pair like this. And what is the carry expression is given by for this term A, and what is the common AB, and for here AB for this BC. So AB plus AC plus BC. You take any order, no problem. So this carry expression, there is another way to write this carry expression is A XOR B into C plus AB. Sir, how do you write this carry expression in this way, sir? Both are correct. Please understand. Why this is also correct, sir? Yes, this is also correct. How, sir? Please listen carefully. Listen carefully. If you don't take the K map and write the expression, it is 0, 1, 1 is A bar BC, A B bar C, ABC bar ABC. इसको थोड़ा सा minimize किया तो without K map you can also write, or you expand this and do you get both of them same. I'm not going to the derivation of this part because I don't want to say. I want to save your time. That is the intention because it is a crash course. I hope you people know, right? चाहिए तो आप expression लिख के try कर सकते. You can prove both are same. Now listen here. You can take one normal what we call. You can take here A XOR B. Its output you can connect to another XOR and you can get the sum A XOR B XOR C. There is another way to do this is AB A XOR B into C. plus AB. Okay. This is how you can make. There is another way to make this is you take half adder. If you give A and B to the half adder, okay. If you give a half adder, you get sum and carry. If you give AB here, sum is AX or B, carry is AB. Now take this output and connect to another half adder. Okay, then if you connect here, this and C you connect it here. What is the sum you get is XOR of these two, AX or B, XOR with C. And what do you get here at the carry? Just multiplication of these two. End operation of these two is AX or B into C. Now take this and take this, connect to OR gate, you get a carry expression, you can check. So full adder is equal to 2 half adders plus OR gate. You can also draw full adder as a single circuit which contains three inputs, A, B and the carry input, and two outputs, the sum and carry output, or carry, whatever you represent, it is your wish. Okay. You can use that directly if the input XOR gate is available, you can use it. But we don't use here is if you want properly, even you use three input XOR gate also to generate the carry, there will be this delay extra. Okay, we should wait for this. So because of that, generally we use this as a representative because XOR internally get A bar B plus AB bar. It requires two AND gates and what we call one OR gate and two inverters while implementing it. So three input XOR gate may maybe more number of transistors will be required. So generally we represent like this. If logically you can represent with direct three input XOR gate also nothing wrong. But hardware point of view generally we can do like this. We implement according to the available number of transistor and the design, the gates available in that particular design. Okay, so let's wait. So you understand here, इसके लिए two gate delays लगेगा. Okay, here maybe three gate delays is required to get the carry, and there is another way to make this also. You can also do like this. You take ABC, A XOR B, XOR C. Okay, now XOR B XOR C. Okay, then you can do AB plus BC plus AC. In this way also you can make the what we call full adder. Here also from one stage to another stage you require two gate delays. Okay, you require two delays to get this. Here you require three delays. Here maybe more number of gates, here less number of gates, but both are logically correct. Fine. So you understand the full adder, you understand the half adder. अगर possibility है तो एक question करेंगे तो सही लगेगा ना? Okay, what is the answer for this? Yeah, please comment your answer. This is a question given in one of the previous papers. In the circuit shown in the figure ABC are the inputs, PQ are the outputs, are the two outputs. The circuit is, what is this circuit? Is it a half adder, full adder? Easy question hai na aapko abhi. Okay. Why to design 4 bit at a time? Because you have input for 3 bits only. Your input is maximum 3 bits, A and B, and carry from the previous case. There is no need of adding 4 bits at a time. Unable to hear me? What happened? Is there any problem यार? बाकी लोग बताओ. Audio सही है ना? Somebody commented that unable to hear me. Yes. So this is a full ladder circuit. Here P is the sum and Q is the carry. Got it? Right. चलो let's discuss now subtraction. Okay. एडिशन तो हो गया, सब्ट्रैक्शन के बारे में डिस्कस कर सकते हैं. थोड़ा सा पानी लेना चाहते हैं. See, check your video resolution. If the screen is not clear, go to settings and make your video resolution to 1080. Okay. Okay, let's start. The next one, we should understand subtraction. Subtraction पे right. First, understand what is 0 minus 0? 0. 1 minus 1, 0. 1 minus 0, 1. अभी तक कोई दिक्कत नहीं, बाकी सभी लोग को पता है, कोई डिफरेंस, कोई डिफिकल्टी तो नहीं है. But suppose you have 15, you want to subtract 9. Can you subtract 9 from 5? 9 5 से 9 सब्ट्रैक्ट कर सकते हैं क्या? नहीं कर सकते सर. क्या करना चाहिए सर? सपोज बेटर टू राइट 25 minus 9. ओके, सो सब्ट्रैक्ट नहीं कर सकते 5 से 9. सो हम क्या करते सर? बोरो लेना चाहिए. वी शुड टेक ए बोरो ऑफ 1. That 1 will become here not 5 plus 1 6. It will become 10. 10 plus 5 15. 15 minus 9. What is the answer? 6. 1 दिया, बाकी कितना? 1. 1 minus 1 0 is the subtraction process. This is how we do the subtraction in our schooling, right? So now, when you take a borrow from higher order to lower order, this becomes 10. Why it becomes 10? Because of its positional value. Because the 2 here is 20, the 5 here is single digit 5. So when you take 1 from here, to the next stage, so the higher stage में 100 होता है, 10 tens 100. So one stage to next stage, what is the multiple? If you take 1, that is equivalent to 10 in the next stage. Why it is tens are? Because it is the decimal number system. If I do the same thing in the binary number system, I want to subtract 0 minus 1. I should take a borrow from higher order, that is equal to 1. After coming, that 1 will become here, because it is binary, it will become 2. 2 means 1 0. 2 means what? 1 0. That 2 minus 1, what is the answer? 1 is the answer. This is called a difference in the subtraction. And this is what we call borrow. Do you understand what I am saying here? 0 minus 1 करना चाहिए, तो 0 minus 1 नहीं कर सकते सर. So आगे वाला stage higher order से we should take one borrow, and after taking that borrow it will become 2, because it is a binary number system. It is in decimal number system, it becomes 10. Here 2 means 1 0 only. Okay, but it will become 2. You keep it in your mind. So 2 minus 1 is 1 is the answer. Okay, here this part is the difference, and this is done by half subtractor. Who will do this job? Half subtractor करते हैं. So you take the two inputs A and B. You have the two outputs, the difference and borrow. So AB can be 0, 0, 0, 1, 1, 0, 1, 1. What is the difference you are getting will be 0 minus 0 mein no difference. No borrow is required. Yeah, 0 minus 1 pay. Yes, I need a borrow. I need a borrow. Okay. And what is the borrow? You take 1. That 1 is equivalent to 2. 2 minus 1 is 1 is the answer. 1 minus 0, 1. No borrow. 1 minus 1, 0. No borrow required. So here the difference is equivalent to same as the previous case AX or B. Borrow is equivalent to A bar. I'm not drawing the circuit and wasting your time. So up to this clear or not, please comment. If it is clear, we can proceed further for the full subtractor condition. Right? Somebody comment to Samreen Sultana. Okay, that voice is clear. Maybe she is having some issue. Please inform to that. Okay. So everybody, is it clear up to this? Up to this clear? Please comment. Please comment. Please comment. I am waiting for your response. बाकी लोग भी कमेंट करना यार. Okay, chalo. Thank you. Now let's go for the next. In the sub, जैसा एडिशन में मैंने बताया, many people don't know this what I am saying. In now we should discuss about full subtractor. Okay, so now let's discuss about the full subtractor. Half subtractor मैंने explain किया ना, same way we should discuss full subtractor. So full subtractor contains three inputs: A, B, BI, and it contains two outputs, the difference and borrow. जैसा full adder में तीन inputs है ना, same condition here also. Full adder में A, B, C, the carry input, carry coming from the previous addition, and you get sum and carry. Here also for the full subtractor you get A, B, B, I, and B and B not. Many people, I can say, if you are not my old student, 90% of the people don't know the meaning of this BI. What is this BI, sir? It is the borrow taken, borrow to be taken, borrow given. What is the meaning of this BI? Please comment. In carry, ABC addition, many everybody knows that C is the carry coming from the previous addition. Same way here also in full subtractor there will be a third bit. Why the third bit comes, I will explain it now. But if you know it, tell me what is the meaning of this BI? What is the meaning of BI? Please comment. Is it the borrow taken, borrow given, borrow input का मतलब क्या? Borrow given to the next stage or borrow taken to the next stage, taken from the higher? What is the meaning of that BI? Okay, so yes, let me explain this. Good, Vandana. Listen here. I will explain. Suppose every time you have a difficulty, first let's have our basics clear. That is with the help of the decimal addition. So suppose you have a number 2343. Let's do this subtraction. Okay. Now suppose what is 3 minus 1? 2, sir. 4 minus 6, I cannot do, sir. I will take a borrow, sir. Okay, take it here. After taking the borrow, it will become 14. 14 minus 6, 8. If it is given 1, what is the answer? 2. 2 minus 1 is 1. Okay, so then 2 minus 1, 1. Okay sir, कोई दिक्कत नहीं, but here you should understand, here also 3 minus 1, here also 3 minus 1. But here answer is 2, here answer is 1. Why sir? Because he has given 1 to the next stage. ये 1 यहीं पे दिया, इसलिए इनके पास 2 ही है, 2 minus 1 तो 1 हो गया. So हम subtraction और subtractor डिजाइन करने समय पे हम क्या करना चाहिए, इसको कंसिडर करके subtraction का subtractor का डिजाइन करना चाहिए. This is the third bit you should consider. Suppose if it is your A and B, this is the BI bit. What is that? This is the BI bit of this particular stage. A particular stage may, this is the BI. This BI is nothing but borrow given to next stage. And this process may, do you take any borrow here? No, this is the borrow taken. Borrow taken or required from higher stage. And this is the difference of one particular stage I am saying. Okay. And here also there is no borrow given and no borrow taken. All those stories the same, right? But I am explaining this particular stage. This particular stage पे what's happening internally. Okay. So 3 1 3 minus 1 तो directly किया तो 2 आएगा. But you should consider one more way while doing this subtraction. The same thing happens in the binary also. Now let's take the example of the binary. 1 0 1 1. Okay. Just now 1 minus 1 0. ठीक है, एक माइनस एक तो जीरो, जीरो माइनस वन कर सकते हैं? नहीं कर सकते. यही से बोरो लाओ 1, it will become 2 here. 2 minus 1 1. Then here it has given 1, but इनके पास कुछ नहीं. पहले एक क्या करेगा, यही से बोरो लाती है. It will bring borrow from here, it will get a 2, 2 से 1 इनको दिया, 1 बाकी है, 1 minus 1 तो 0. 1 इनके पास है, 1 इनको दिया, what is the balance? 0. 1 is having, 1 is given, what is the balance? 0. 0 minus 0 is 0. This is how the subtraction takes place in the binary. It is in binary and speaking. Okay, this is the borrow taken for this particular, this is the borrow taken for this is the borrow given and borrow taken, and the difference you will be getting. So to analyze all these three, we should take what we call the borrow given already, okay, is to be considered. This is the borrow given, okay, this is the borrow to be taken. Now okay, see here carefully. If there is no borrow given, it is just the same as half subtractor. 0 minus 0, no difference, no borrow. No borrow is given, 0 minus 1, same answer. 0 minus 1 pe, you should take a borrow of 1. No borrow given, 1 minus 0 is 1, no borrow. No borrow is given, 1 minus 1, 0, and no borrow required. Now, if borrow is given, how the answer will change? See here, we are considering A, B, 0, 0, borrow not given, borrow given condition. So, इस केस में क्या होता है? इनके पास कुछ नहीं, but इनको 1 देना चाहिए. Borrow 1 is to be given means it should take first borrow. It will get 2, 2 में 1 दिया, 1 बाकी है, 1 minus 0, 1 is the answer. Here, okay, you don't get this explanation in any book, you can cross check it for sure, okay. In any video also I can join. So देखो इसमें क्या होता है सर, मेरा पास 0 है, मैं इनको 1 देना चाहिए तो पहले I should bring borrow of 1, then I'll get to 2, 2 पे 1 इनको दिया, 0 minus 0 is 0, no borrow required. I have 1, I have given that 1, so I will be left with 0. Now 0 minus 1 के लिए पहले borrow लाओ, 2 you will get 2 minus 1 1. This is the original way to explain the full subtractor, but shortcut में ऐसा भी कर सकते हैं. 0 minus 0 is 0, 0 minus 0 is 0, 0, 0 minus 0, 0 minus 1 is 1, 1, 0 minus 1. Okay, you should take a borrow. Okay, uh, here it is 1, 1. 0 minus 1, you have 0, you have given that, but you should subtract 1 ना इसके लिए. What will you should take a borrow of 1 and you get a what we call the difference of 1, right? Same here, 0 minus 1 is difference is 1, 1 minus 1 is difference 0, and so on. You can directly do it. So what is your difference here is the sum of the mean terms 1 to 4 7. It is the same as carry of your full ladder ax or bx or c, if you take it as a abc. Okay, or borrow ba. What is your borrow? It is sum of the mean terms 1, 2, 3 and 7, that is given by a bar b plus a bar c plus bc. How I am saying directly, after solving from K map you get this answer. ठीक है, मैं K map तो solve नहीं किया time save करने के लिए. And another way of writing this expression answer is a xor b whole bar into c plus a. Both are correct. Okay, it is as simple as whatever you have done in the adder, इसमें a का जगह पे a bar आएगा, बाकी तो same. I'm not drawing the circuit also. Here also we can prove that one full subtractor is equal to two half subtractors plus OR gate. That will finish the basic arithmetic circuit addition and subtraction. Basic arithmetic operation of addition and subtraction. Okay, so let's move further. So let's have one question. Yep. So please try this question and tell me the answer. Give it a try. Now it is clear about subtractor, right? Yes. Okay. What is the answer यार? आंसर तो कोई नहीं दिया. क्या हुआ? आंसर नहीं पता क्या? Okay, let me. I think there is a mistake. That is the reason you are not able to do it. Wait. Okay, no problem. Um, this is AX or B. So A XOR B XOR C. Okay, this can be your sum, this can be your difference, it can be full adder or full subtractor. It depends on this result. Okay, so here you have A bar B. Here what is the answer? Yeah. A bar B plus BC तो गलत है ना. It is none actually. Hmm, I can do some modification. AC तो मिस हो रहा है. Yeah, there is actually it is none. Okay, because it is giving you BC. What is the answer? A bar B plus BC. It doesn't make any sense. Oh, sorry. This is BX or C. Acha. Wait. Let's do it. So this is BX or C, and this is A bar. So A bar into B XOR C, and this is DC. So what is this expression is A bar into B bar C plus BC bar plus BC. Okay, so this can be written as A bar B bar C plus A bar BC bar plus your BC. I am changing BC into A plus A bar. Why BC into A plus A bar? Because A plus A bar to one है ना, one into anything will give you same. So I can write BC as ABC plus A bar BC. This is called converting normal into canonical. Okay. So now what is this 0 0 1 0 1 1 0 दो बार आ रहा है ना. ए पी सी बार आना चाहिए. एक मिनट. जस्ट a minute. Actually none आ रहा है, but I can modify the question to go give your our required result. A bar 1 2 3 7 चाहिए ना. This is giving 3 only again, but it is also not correct. It is giving you sum of the minterms 1 3 7. नहीं, आपको क्या चाहिए? 1 2 3 7 चाहिए. It is not representing borrow, not representing carry. I'm just give me 1 minute. How to convert this into C bar? Okay, leave it. So here answer is none. Okay, 1 2 3 7 तो नहीं आ रहा है, 2 तो मिस हो. और okay, this is C bar. Now it is correct यार. मैंने confuse हो गया. Because A bar B bar C, A bar B C bar. So 0 0 1 0 1 0. So 1 2 and 7 and 3. So sum of the minterms 1 2 3 7. So this is a full subtractor. Chalo. Next. Okay, let's do the next question. Thank you. Now, Very important part, I mean most frequently asked part we are going to discuss, that is called adder circuit. So now the next part we are discussing is 4-bit parallel adder, or this is also called as another name, ripple carry adder. What is the name? Ripple carry adder. ये है दूसरा नाम. Okay, 4-bit parallel adder or ripple carry adder. ठीक है. Suppose you have a 4-bit number A3, A2, A1, A0. You want to add with another 4-bit number. Then how to do this is given by a ripple carry adder or a 4-bit parallel adder. So let's discuss that. ठीक है, इसके लिए मैं 4 full adders ले रहा हूँ. ठीक है, so 4 full adder ले लो भाई. Okay. Okay, listen. So there are, I have taken 4 full adders. I am giving the names FA3, FA2, FA1, FA0. Okay. And you have the carry C naught equal to 0. You get the sum. Okay. So you have the inputs A naught, B naught, A1, B1, A2, B2, and also A3, B3. चलो भाई ध्यान से सुनो, लिसन केयरफुली. I want to do the addition of A3, A2, A1, A0 with V3, V2, V1, V0. How to do normal addition, sir? First we add A0 and V0, we get the sum and carry. Carry propagated to next stage. Then we add them, you get the sum and carry. You get the carry here. Add them, you get the sum and carry. Add them, you get the sum and final carry. The same thing, others, whatever you are seeing here, इसमें जो है ना सेम काम कर रहा है ये वाला सर्क्यूट. कैसा कर रहा है सर? मैं नॉट बी नॉट को ऐड करके सम देता हूं सर, और कैरी आई विल गिव इट टू द नेक्स्ट स्टेज. दिस इज माय सम एंड कैरी ऑफ द फुल एडर. Then again I will be getting the sum, sir. मैं carry को next stage को दे रहा हूँ sir. So I will be getting the sum, sir. I am giving the carry to the next stage, sir. I will be getting the sum and the carry, sir. This is the process of the 4-bit parallel adder ripple carry adder. इसमें क्या दिक्कत है सर? दिक्कत तो ये है, अगर ये एडिशन होने के बाद इसको कैरी मिलेगा, देन इसका एडिशन हो जाएगा, देन इसको कैरी मिलेगा, इसका एडिशन हो जाएगा, इसको कैरी मिलेगा. सो एवरी स्टेज, एट एवरी सिंगल स्टेज, to get the carry input to the particular stage, we should wait for the carry output of the previous stage. Until I will get this carry, I cannot do this addition properly. I don't get a valid result until this addition is completed. And here we don't know the internal circuit of this particular what we call full adder. इसका internal circuit में it may be designed by using 2 XOR or 3 XOR, 3 AND gate or gate, or 1 XOR gate and gate. Different representations are possible that we don't know. Okay. So in exam, very important question is the total delay required here. The total delay is given by the formula of you should wait for carry 1 time, 2 times, 3 times. So you can say n minus 1 times I can wait, I need to wait for the carry, plus after giving all the carries you should wait for the final result. Final result में दो पार्ट है, sum और carry. So which one will come late, we should wait up to that particular time. इसलिए that is the total time taken is maximum of sum and carry, where TC here is the propagation delay. That is the time required to get the output after applying the input, the valid carry. Okay, of carry of one full adder. What is the TS, sir? The propagation delay of sum of one full adder. ठीक है sir. So by the time last 3 times you should wait for carry. Last stage में you should wait for maximum of sum and carry. By the time you get its sum, other sums are already available because इसका inputs are applied little early. So we should wait for the last one only because that will come at the last. Okay. By the time you get this sum, all these sums are already ready. Okay. So you can see here, this is what we call the problem with the, this is the delay. So here when n increases, delay increases. We can overcome by CLA. What is CLA, sir? Carry, look ahead, adder. We will discuss that next. Now see here. Similar to addition, we can also design the same circuit. Adder का जगह पे subtractor रख के हम काम कर सकते हैं, ठीक है. So adder का जगह पे subtractor को full subtractor रखेंगे तो this full adder 4-bit parallel adder will become 4-bit parallel subtractor. But computer के अंदर अगर हार्डवेयर पॉइंट ऑफ व्यू हम सोच लिया तो if you think with respect to hardware in the computer, if you take a separate circuit for doing addition, separate circuit for performing the subtraction, it will be what we call increasing the hardware. So we should avoid this to save the hardware. हमारा हार्डवेयर सेव करने के लिए अगर पॉसिबिलिटी है तो हमेशा हम ये ट्राई करना चाहिए to make a single circuit which can do both the addition and subtraction, so that I can save the hardware. Hardware save करने के लिए एक ही circuit दोनों काम करने वाला हमको required है, ठीक है. You need that. Okay. हमको हमेशा ये चाहिए जो दोनों काम करेगा, एडिशन वाला काम और सब्ट्रैक्शन वाला काम. So if that is possible, it is more advantageous. Yes, that is possible with the help of circuit called as universal adder and subtractor. We will discuss that. इसके पहले What is the problem here? N increases, delay increases. इसको कम करने के लिए we should go for carry lookup adder. Sir, carry lookup adder का मतलब क्या है sir? It will add at each and every stage without depending on carry from the previous stage. ये दिक्कत यही पे है ना? So here the carry input, since the Cn at present state depends on Cout from previous state. Delay increases with increase in number of bits. We can overcome by using carry look ahead, where carry is generated without depending on the previous carry at each and every single stage. Okay, that we will discuss next. Okay, so that is about your parallel adder. Now subtractor, adder का जगह पे subtractor replace कर सकते हैं, but now we are discussing a circuit. Two circuits तो discuss किया तो arithmetic part तो हो जाएगा. That is BCD adder I am not discussing. Other than that, universal adder and subtractor and carry look adder. Then we do corresponding problems. Then I will discuss comparator, multiplier, and I can end the class for today. Okay. So थोड़ा सा time लगेंगे तो भी please adjust. Himanshu, you are asking the same question every single day. मैं तो आपको reply भी दिया already yesterday class में भी. Okay. Presently कुछ नहीं. अगर कुछ possibility है तो maybe in future they might plan. Directly VLSI के लिए कुछ नहीं. But basics के लिए always you can prepare for the gate network digital what we call analog circuits, EDC and all. So chalo, let's move. Universal adder or subtractor. Here, please listen carefully. This is the circuit which should be able to perform addition and subtraction. So इसके पहले आपको ये पता होना चाहिए how to perform subtraction using addition. So we are discussing how to perform subtraction using addition by 2's complement. Okay, so let's discuss this. If you want to do a minus b, it can be written as a plus 2's complement of b. What is 2's complement? 2's complement is 1's complement plus 1. What is 1's complement? Yesterday class I have given r's complement concept. नहीं है तो भी ठीक है, कोई दिक्कत नहीं. 1's complement is nothing but just what we need to do, replace 0 with 1, 1 with 0. For example, you have number 3. 3 means what? 0, 0. 2 bits ले लो, please. 1. What is 1's complement of 3? 0, 0. Replace 1 with 0, 0 with 1. What is 2's complement? 0, 0 plus 1. This is the 2's complement. Suppose you want to do 5 minus 3. You know answer is 2. It can be done with the help of 5 plus 2's complement of 3 also give you same answer. What is 5? 5 is 0, 1, 0, 1. Okay. What is 2's complement of 3? Okay. For example, 3 is there. Take two 4 bits here, 0, 0, 1, 1. It will become double 1, double 0. So double 1, 0. Okay, 3 means double 0, double 1. What is the complement of 3 is double 1, double 0. Replace 1 with 0, 0 with 1. So 5 minus 3 is equal to add 2's complement of 3, that is double 1, 0, 1. What is the answer? 1 plus 1, sum 0, carry 1. 1 plus 0, 1. No carry. 1 plus 1 plus 1 plus 1, sum 0, carry 1. 1 plus 1, sum 0, carry 1. Neglect this carry. What is the answer? 0, 0, 1, 0 is plus 2. If you get minus 2, your answer will be no carry will come. It is a negative answer. If this carry comes, neglect it. If you need to do 3 minus 5, in that case you don't get carry and your answer will be in 2's complement. That indicates the answer is negative. Okay, so you understand now. I can do subtraction using addition. इसका logic क्या etc. हम regular class में discuss करते हैं. I can have given the basic reason why this how it is possible and all. Okay, suppose you want to do 60 minus 20. Okay, you can also do that as what is 100 minus 20? 80. Na? So 60 plus 80 also will give you same answer. So 60 plus 80 answer kya? 140. Na? This also give you same answer. So this logic is used in 2's complement. Okay. So because what is 60 plus 100 minus 20? 0, 4, 1. So this 40 will tell you what is the value of 60 minus 20. The same, this is nothing but R's complement. Why, sir? Why you can do directly 60 minus 20 now? Why you are doing all these things, sir? If you neglect this, what is the answer now? Okay, because it makes my hardware implementation easy. I can easily find this value of 2's complement by just using inverter. I don't do actually here subtract. Here maybe in decimal you need to do subtraction, but in binary the 2's complement or R's complement is easy with the help of inverter. So which saves my hardware and the time. So that's why we use this trick to do the subtraction with the help of addition. But we should find complement first and add it. So complement ke liye we don't do subtraction. Originally complement is obtained in this way. Okay, but we don't do that. This is for understanding of theory. Practically we implement with the help of inverter or whatever. I will show you now. Okay, so this is the logic behind the complementary representation. Chalo. This also many people don't know. Only directly we can. Many books will explain that, but the logic behind this is this one. Okay. Better way may I generally explain the comprehensive course. Now, see here. Let's design this. Before that, one more thing you should know. As and when it is required, I am giving you basic. What is 0 XOR 0? What is 0 XOR with 1? 1. So I can say 0 XOR B. What is the answer is? If you have 0, you are getting 0. If you have 1, you are getting 1. It is B. Accepted? The same way. What is 1 XOR 0? 1. What is 1 XOR 1? 0. If one of the input is 1, other input is B, what is the answer you are getting? What is the other input ka complement you are getting? Na? So use this basic. Okay, we are going to use this basic. Chalo. Okay. One more thing. Here, because the carry input is first stage mein carry input is 0 now. So you can replace this can be half adder also okay. Why sir? Because you are adding originally 2 bits only here. So you can say n bit parallel ladder requires n full ladder. Another answer is n minus 1 full ladders, one half adder also sufficient, because last stage don't require full ladder. But one full adder is equal to two half adders now, because one full adder can be made with two half adders. Okay, that's one more half adder. That will give you 2n minus one half adders are required. It is given in one of the exam to make n bit parallel. If you may require OR gates also, plus because n minus two half adders, one OR gate will give you that one. OR gate नहीं दिया तो ठीक है. Why this, sir? One full adder is equal to two half adder plus OR gate. If you want to implement this with half adders, you require 2n minus 1 half adders. Here n is 4, 2n minus 1 is 7, and what is that? N minus 1 OR gates. Chalo. Now let's make this universal adder. Okay. Chalo bhai, listen. Suppose your control equal to 0. What will you get? Sir, 0, sir. And 8 minute. Suppose control equal to 0. क्या होता है सर? कंट्रोल 0 है तो ए इनपुट 0 0 0. ठीक है सर. ओके. सो 0 में तो अभी बताया ना, 0 एक्सऑर विथ बी आपको क्या होता है सर? 0 एक्सऑर विथ बी इज बी. सो यहीं पे बी नॉट, बी वन, बी टू, बी थ्री आएगा. एंड नाउ व्हाट इज दैट? I'll write here. When control equal to 0, it is doing A3, A2, A1, A0. And what is the other input that you will getting? B3, B2, B1, B0. And what is the carry input? 0. It is nothing but A plus B. It is performing just addition only. ठीक है sir. नाउ मैंने कंट्रोल को 1 करेगा सर, लेट्स चेक व्हाट हैपेंस। अगर कंट्रोल को 1 किया तो क्या होता है सर? सो कंट्रोल का इनपुट को 1 करो भाई, ठीक है। सो कंट्रोल को 1 करो, 1 करो, ठीक है। व्हेन कंट्रोल इनपुट इज इक्वल टू 1, देन व्हाट इज वन ऑफ द इनपुट 1 है तो XOR गेट विल गिव यू कॉम्प्लीमेंट। सो हियर इट विल बी B3 बार, B2 बार, B1 बार, B0 बार, ठीक है। सो व्हेन कंट्रोल इक्वल टू 1, A3, A2, A1, A0, सो B3 बार मिलेगा, B2 बार मिलेगा, B1 बार मिलेगा, B0 बार मिलेगा, एंड C0 is equal to 1. This is nothing but 2's complement. So it is doing A plus 2's complement of B, which is nothing but A minus B, which is nothing but subtraction कर रहा है sir. So same circuit is doing both the addition and subtraction. I need not take another circuit or another full add, another full subtraction. Simple extra एक gate है तो हमारा काम हो रहा है, ठीक है. So that is the advantage. So it can do both the addition and subtraction. So it can do the subtraction when control is equal to 1, and it can do the addition when control equal to 0. ठीक है. चलो let's चलो listen. Let's do some questions. First question is ready for you. आप लोग तो आंसर कर लो अभी. Do it. Okay, time up. Okay. It performs addition. ये ना equation क्या हुआ एक भी आंसर नहीं दिया 195 right answer. So here what is the formula I have given you? n maximum of someone can. So n is 16 minus 1 into carry ka 15 maximum of 15 comma 12. So it will be 195. Please listen here. Use this formula when input and internal circuit not specified. Because if input is specified now for different inputs, the delay will be different. Because if input is 0, it may not require any time to do the addition. Like that, similarly, internal circuit will also decide how much time is required for the carry. This is a generalized rough way when nothing is specified. Okay. So maximum. Next question. So this is also a similar question. Chalo. Ready? Give it a try. Last 10 seconds. Time up. So what is the answer here? Firstly, tell me what is your y? Here y is equal to p XOR q XOR r. Okay. Z is equal to p bar q plus p bar r plus qr. It is in the form of a bar b plus a bar c plus bc. आप ध्यान से देखो, this is in the form of a XOR b XOR c. So it can be either sum or difference, but this is not carry, it is definitely borrow. So compulsory, this is a subtractor circuit only. So it is not doing any addition, it is doing subtraction. So how to justify whether it is doing P minus Q or Q minus P? इस केस में it will do A minus B. So इस केस में it will definitely do P minus Q. How sir? Because the bar is with P. Bar is with P. Okay. So it is the circuit which does P minus Q. If it is Q bar P plus R bar, what we call Q bar R plus RP, in that case, maybe it is R minus P. Okay, but here bar is with this because we have done the what we call design or what we call derivation for A minus D, A is having the bar. Same way, derivation P minus Q may P will be having the bar. That is the logic. Is it okay? Yes or no? Next question. Try this. Answer please. Time up. This is a good question, yeah. A half adder is implemented with the XOR gate and AND gates. A full adder is implemented with two half adders and one OR gate. The propagation delay of the XOR gate is twice that of AND gate or gate. Okay. If the propagation delay of AND and OR gates are 1.2, 4-bit triple carry adder is implemented using 4-bit 4 full adders, the total propagation delay of the 4-bit parallel adder. Anybody, if you want a little more time, you can take, but give it try. Many people don't read this question also because they don't want to read it. They don't want to understand. But if you read and understand, there is a chance you can definitely answer the question. It is not much difficult. थोड़ा सा patience चाहिए, definitely you will be able to do it. Okay, let me do it. Full adder is made with two half adders and OR gate, right? Right. This is A and P. So output of this is given to another. This is what we call your sum and carry. Now examiner is saying that AND gate is having a propagation delay of 1.2 seconds and XOR is having 2.4. So it's made 2.4 delay. 2.4, 1.2, 1.2. Now you made a 4-bit parallel ladder like this. So let's see how it will work. Mhm. Just a moment, please. Okay, leave it here. Why to draw? Waste your time. Sure. Listen. If you give some input here, it requires 2.4 nanoseconds to get the output, first stage for example. Okay, because in the first stage there is no carry. Na? The second stage mein the carry will be coming from this carry. Okay, so this is the C1, C0. Okay, please understand here. This requires 1.2 nanoseconds. Okay, and this is the 2.4 plus 1.2. This will come at 3.6. Now 3.6 plus 1.2. How much time is required to give the carrier? 4.8. And how much time is required to get the sum here? Because C naught is applied at time t equal to 0. 2.4 mein this is applied plus another 2.4, 4.8. For sum and carry. You don't use the formula n minus 1 times carry plus maximum of sum and carry. That doesn't work in this case because internal circuit is given. I told already, don't apply that. Okay, now see. Once you apply the carry, okay, already these inputs are applied at time t equal to 0 itself. Yes or no? So 2.4 nanoseconds may already this is available. 1.2 may this is already available. Now this carry input comes at 4.8. This will come new at 4.8. So after 4.8, another 2.4. So 4.8 plus 2.4. 7.2 nanoseconds. Here also same story na. After 4.8, you get this part is 2.4 na. At 4.8 you have applied the carry. Then another 2.4, 7.2. Okay. So next answer will come. Okay, for this is for FA1. For FA2, 7.2 may carry coming na. After that, another 2.4 is required. 9.6. For full adder 3, 9.6 plus another 2.4, that will give you 11 nanoseconds. That is the answer. Okay. So generally what we do n minus 1 times carry plus maximum of sum and carry, that doesn't work here because the internal circuit is given. We should do accordingly. So it requires 4.8 to get the first stage ka sum and carry. After getting that carry, okay, this gate requires another 2.4 and this part requires another 2.4. So after giving this carry, already the other inputs are readily available because of AB is available at time t equal to 0 itself. So we get remaining already available. So 4.8, another 7 point, another 2.4 it is requiring. So another 2.4 for next, another 2.4 for the next case. So that's why I told in the earlier case, when internal circuit is given, don't apply the formula directly. We should do it carefully. So 11, 9, 12, 12 nanoseconds is the answer. ठीक है, so 12 nanoseconds. चलो next question. So full adder can be implemented with half adders and OR gates. A 4-bit parallel adder without any initial carry requires how many adders? Give it a try. Okay. Here it is a simple question. 2n minus 1 half adders plus n minus 1 OR gates. 2 4s 8 minus 1 half adders, 3 OR gates. 7 half adders plus 3 OR gates. ठीक है, 7 half adders and 3 OR gates. Try this question. You can comment your answer. What is this circuit? Just tell me. Okay. Here we have discussed just now. So when the switch is here, you are connecting 1. When switch is at position 1, you are connecting 0 now. So it is what it is doing. Switch position 1 पे है तो it is giving you 0 means addition. When the switch is at position 2, it is doing subtraction. What, by which particular method? By 2's complement arithmetic. Okay, this is what we have already discussed just now. Universal adder circuit. This question is done. Okay, this is done. Let's do this. Then I explain carry locate adder and we can end the class for today. This is not adder but general question. Last full adder does not require one full adder equal to 2 half adders only, but here the last stage does not require any adder. Yes or no? Here 2n minus 1 because the last stage is only half adder is sufficient at the LSB. That is already discussed here. Okay. This here operator is sufficient. Remaining को full letter equal to two operators. Okay. चलो. No answer. चलो. Listen. A circuit represents digit in the form of 4 bits, 0 represented by all zeros, 1 represented by 0001, 9 is represented by 1001. A combinational circuit is designed which takes 4 bits as input and output is equal to 1. If the input is greater than or equal to 5, output is 0, output is 1, otherwise it is 0. So let's take a K map first. Excuse me. Okay, listen. So circuit outputs the digits in the form of 4 bits 0 to 1. Okay, when a combination circuit is to be designed which takes 4 bits as the input and output 1 when the input is greater than or equal to 5. So 5, 6, 7, 8, 9 by 1. But input is in the range of 0 to 9. So the inputs which doesn't occur, we take it as a don't case. 10 to 15 doesn't occur. So now you can make a quad and octet. What is the function? So for this quad, it is B, D. For this, it is BC. And for this, it is A. So the function is A plus BD plus BC. A plus BD plus BC. Okay, this is one way. नहीं है तो A plus take B common C plus D. So C plus D into D. Okay, how many gates in any method? 3. Here only 2 input gates are used. Here 3 input gate is used. But the number of gates required will be 3. Okay, chalo. Let's go for the next. Okay, so the last part of today's class. Carry look ahead. Okay. So for carry locate adder, why we should go for carry locate adder? Because when we have a parallel adder, when the number of bits increases, delay increases. To overcome this, we take the help of carry locate adder. In the carry locate adder, it will generate the carry at each and every stage without depending on the carry of the previous stage. So here, let's see how to generate the carry. What is the rule for getting the carry? Suppose you have a two bits A and B. They can be 0, 0. 0 1, 1 0 or 1 1. 1 0 or 0 1 doesn't make any difference. So the carry input can be 0 or 1. Carry input can be 0 or 1. Now, if you add them, okay, so here, okay, see please, don't think it is a 2-bit number, single, okay, you should read like that. 0 plus 0 plus 0 is sum 0, no carry. What is 0 plus 0 plus 1? Sum 1, no carry. Here also, sum 1, no carry. Here, sum 0, carry 1. Here, sum 0, carry 1. Here, sum 1, carry 1. So, in this case, what is the carry you are getting? This is the carry. This is the carry. Tell me. 0. No carry. When AB are 0, 0, your scene can be 0 or 1, doesn't matter, carry will not occur. But when AB is 0, 1, okay, now see, if the scene is 0, you get 0. If scene is 1, you get 1. So, C naught is equal to, this is the C out, C in here. We call this as propagate carry. Here, whether you have a carry here or not doesn't matter. Always C naught is equal to 1. We call generate carry. When will you get generate carry, sir? When A and B both are 1s, you represent AB. Propagate carry occurs when any one of them is 1, we can represent with AX or B. So to get a carry, finally, what is the required condition is generate carry should occur. That is, when both A, B are 1s, no need to worry about C, you get a carry. Or propagate carry can occur with carry input equal to 1. If carry input is 1 and propagate carry is true, that is AB is 0, 1 or 1, 0, with Cin equal to 1, in that case also you will get the carry. So this can be written as AI BI plus AI XOR with BI into CI is the expression for the carry. You can also write this as AI BI. After minimization, this can be written as AI plus BI into CI. Some textbooks will give propagate carry as XOR, some will give you X plus, both are correct. So finally, what is the carry formula? Is to get the carry in the next step, you should generate carry or propagate carry with CI. Using this formula, we design an adder circuit which can generate the carry at each and every stage without worrying about the carry in the previous state. That is what we call carry look ahead adder. So let's discuss the 3-bit carry look ahead adder. Okay, 3-bit carry look ahead adder. Listen. Now see, what is the carry in the first stage? And you can also say sum is AX or B, na? PI XOR with CI, because that is equal to, what is the carry in the first stage is given by G naught plus P naught C naught. What is the carry in the second stage? G1 plus P1 C1. Substitute C1 expression here. Because originally what we do, we take C1 and connect to the next stage. But that should not be done. We should generate C1 again here. What about C3, sir? It is G2 plus P2 C2 by using this formula. So G2 plus P2 into multiply the expression of C2. Right. Now listen here. Let's design a circuit and understand how it is improving the delay. Firstly, A naught, V naught, A1, V1, A2, V2. Okay, that will give you G naught, sorry, P naught, G naught, P1, G1, P2, G2, C naught. Okay, now listen here. First gate is G naught plus P naught, C naught. Next G1 plus P1, G naught, P1, P naught, C naught. Next G2, P2, C2, sorry, P2, G1, P2, P1, G naught. Just I am writing this here. Right. Suppose this is the circuit of 3-bit carry generator circuit. आप calculate कर लो delay कितना है इसमें. Suppose this requires 1 gate delay, both of them parallel. This requires 2 gate delays. This requires 1 gate delay. Total carry के लिए 3 gate delays. Sum के लिए 4 gate delays. It is independent of n. N value can be anything. It doesn't matter. The answer will remain the same. N का value कुछ भी हो सकते हैं. N का value कोई भी ले लो. It will increase vertically but not horizontally with the increase in the n. So what happens? The number of gates may be more, but the delay is fixed. It is not depending on the delay of the previous state. Let the carry in the next state. Here, number of gates is the important question. What is the in carry generator circuit? Number of OR gates is equal to, suppose 3-bit mein, what is the number of OR gates in the output? 3. That is n. What is the number of AND gates? Only generator circuit and state. 1 plus 2 plus 3. Normal answer is 1 plus 2 plus and so on n. N into n plus 1 by 2. So here when increase in the n, maybe the number of gates might increase, but not the delay. Delay will remain same, provided if you have more number of input gate. Otherwise, if you make this n input gate by cascading different gates, maybe it increase the delay. So to improve the propagation delay, we can go for the carry located. Okay. So sum is equal to P is A XOR B na, that XOR with C will give you sum. Chalo. Now try to answer this question. Try this question. Read it. Please read and give your answer. Try to answer the question. In a look-ahead carry generator circuit, carry generate function GI and carry propagate function PI. Inputs are A and PI. Sum is given by P XOR C. Carry is given by GI plus PICI. C naught is the input. Then consider the two-level implementation of the look-ahead carry generator. Assume what is carry generator here is this one. This one is the carry generator. Okay. So assume that PIGI, that number of AND gates and OR gates needed to implement 4 bit. What is the answer? AND gates 4 into 4 plus 1 by 2. OR gates. Okay. Okay. So similar model, one more question. Give a try. Give a try. Here, very same question. A 4-bit carry lookup adder which adds the two 4-bit number using AND or not NAND gates only, assuming that all inputs have available in both complement and uncomplement form, the delay of each gate is 1 time unit. The overall propagation delay of the adder. Here he has given AND gate, OR gate, but not given XOR gate. See here, it is an AND OR, right? Carry generator, right? So here you have an AND gate, you have an XOR gate. This is the circuit, right? This requires two gate delays. But XOR is not given. How to make XOR? A XOR B equal to A bar B plus A B bar. So A bar B plus, here are both complement and uncomplemented form are available, he told. So this requires two gate delays. So normally XOR requires one gate delay is what we have taken, but in this example it takes two gate delays. In that case, total will be six gate delays. Okay. Can we do this with less than six is the question. That is not asked by examiner, but we can do it. Okay, I'll show you. This is the AND OR. You take generate carry. Propagate carry need not be XOR gate. I already told you propagate carry can be OR gate also. Okay. Then here sum is equal to A XOR B XOR C. Here you get C. Okay, or Ci plus 1, whatever it may be. Okay, now this, okay, A XOR B you should take. XOR gate requires two gate delays. Now this is AND OR logic. Here I don't use XOR, I use OR. So this is one gate delay only, two gate delays only. So this requires three gate delays. So this input is applied at three gate delays, but this XOR requires two gate delays. So two gate delays, but input by whichever comes late, we should consider that only. So 3 plus 2 total will be 5 gate delays. We can do it. But examiner gave 6 in the option, we should take 5 is not available. Examiner has made in this way. He has used it for propagate carry XOR gate. In that case, we can directly use P XOR C, no problem. Okay, but if propagate is not made with the XOR gate, you can also make with OR gate. But here sum is always A XOR B XOR C only. If if propagate carry is made with XOR gate, no problem. Directly you took P XOR C. Nahi hai to you can use here OR gate and A XOR B XOR C you can use like this. So when XOR is not available directly, maybe you can save the delay. Maybe extra OR gates are required. Okay, so here what is the answer is 6. So that will finish most of the arithmetic circuits part here. We have one more thing, just 1 minute I'll take and I will end the class. Multiply. If you have A1, A0, you want to multiply with B1, B0, what is the answer you get is A0 into B0, that is AND operation of these two bits, then AND operation of these two bits, then AND operation of B1, A0, B1, A0. Add them. While adding, you should take S0, sum and carry, because addition means not OR operation. Addition means sum and carry. Sum and carry. So, how to make this is A0, B0, B0, A1, B1, A0. Now, sum is done with the help of XOR. C2. Now, add them again. Addition is always equal to sum and carry. This is how, this is nothing but a half adder. This is how we can make a binary multiplier by normal without any minimization and all. At home, if you want, you can practice like this. A1, A0, B1, B0. You take here 4 zeros to 4 ones. What is the answer? 0 into 0, 0. 0 into 1, 0. 3 into 1, 3. You take this as one number, this as one number. 3 2 is 6. 3 3 is 9. Now, y3, y2, y1, y0 minimized by k map. That you can try as a 1 minute, last one. Because it will finish this part, first part of combinational circuit. The next one we should know is one bit comparator. It's a logical circuit. One bit comparator means I want to compare A greater than B, A less than B, A equal to X, Y, Z, 0, 0, 0, 1, 1, 0, 1, 1. When will you get A greater than B, sir? 0, 0 means A equal to B. 0, 1 means A less than B. 1, 0 is A greater than B. 1, 1 is A equal to B. So A greater than B is an expression for A B bar. This is an expression of A bar B. This is expression A X naught. Okay. So A, you see here A B bar, A bar B, Z. This is what is the answer is A bar B plus. Okay. This is called one bit comparator. This is how you can compare two bits and say whether A is greater than B, less than B, equal to B. Similar to that, we can have two bit comparator also. That is A is A1 A0, B is B1 B0. Okay. If a particular bit is a single bit is greater than that, I represent with Xi. That is a AI Bi bar. If a single bit is less than this, I represent with Yi. A bar Bi. If a single bit is equal, it is Zi. That is Ai XNOR with V. Okay. Now see here carefully. When will you get A greater than B? If two bit number A1, A0, B1, B0, A greater than B, when will you get? A1 should be greater than A0. If first bit is more, I can say A is greater than B. Or first bit is equal and the second bit is more. Yeah, just a minute. A1 greater than B1 or A1 equal to B1 and A0 greater than B0. This can be written as X1 or Z1 X0. When will you get A less than B? Reverse. A first bit is less, or if you take the two numbers, first bits are same, but second bit is less. In that case also, Y1 or Z1 into Y. When will you get A equal to B? First bit is same and also second bit also same. Both the bits must be same, then only I can say A equal to B. Now you can do this as a homework. You take A1, A0 as one number. You take here all zeros to all ones. And fill this table. First, tell me X, A equal to A means these two bits. Are they equal? Yes. A less than B na? A less than B na? Here, A greater than B na? A equal to B. Like that, fill it. Solve x, y, z, y, k. I am writing the answer directly. X will be sum of the midterms 4, 9, 8, 12, 13, 14. So y will be sum of the midterms 1, 2, 3, 5, 5, 6, 7. How I am writing, sir? 15 means what? Double one, double one. X equal to y. Na? 11 means what? 1, 0, double one. X less than y. Na? Sorry, A less than B. So one exam they asked how many times this occurs? 6 times. How many times this occurs? A greater than B, A less than B, A equal to B. Okay. This happened 6 times, this happened 4 times. Right. That will finish my job for today. I'm done with the arithmetic and logical circuits for you. In the combinational circuits, we left over with switching circuits that we will be discussing tomorrow. That is mux, demux, decoder, encoder, all these stuff we will be discussing tomorrow. So tomorrow also we have the class, and day after tomorrow I don't take any class. Again, we will resume the classes from Monday or Tuesday because of some festival and weekend. I am next 3 days. After tomorrow, I don't take. See, guys, please understand even I have many works, I can take my plus courses, crash courses, anything, but still, because many digital, I have seen some students are facing difficulty in the digital while taking some marathon session. I understood this is the subject where the people should score. With all that concern, I have started by taking the extra pain, and whether you come or not, I show my sincerity by taking the class every single day. When I make a shot that how many are interested, many people commented. I don't know what happened to those people. Sincerely, I am saying that if you are not interested in any course, never comment that we will be coming, never promise that we will be coming. The teacher who is really sincere will be worrying because of the you people are, he will be losing his sincerity that affect many students who are really sincere. Okay, अब लोग sincere नहीं है तो कोई भी course के लिए when we ask the question, are you really interested? Please never comment that we are interested, sir. We will come, sir. ऐसा मत करना, ठीक है? आप कोई भी course में interested है तो really tell the same thing and attend the classes regularly. Don't miss the classes. आधा काम किया तो कुछ नहीं मिलेगा. This is the course where you just come to the class for 15 to 20 hours. आपको पूरा डिजिटल में कोई भी क्वेश्चन आएंगे तो you will be able to solve in your examination. That will happen for sure. Okay. So that is from my side. So we will continue this series, guys. No doubt in it. मैं तो प्लान किया मैक्सिमम 20 आवर्स के अंदर मैं पूरा नेटवर्क डिजिटल को कंप्लीट करेगा. Those who come regularly, definitely they will face the advantage. So these things we will discuss tomorrow. So after the class, please share this link with your friends and comment uh, regarding the class so that it can reach many students. Yeah. So this is my Telegram channel code. आप लोग इसमें आ सकते हैं and you can for notes and other communication, and also you can join my classes, and you can, if you want to take any plus subscription, you can use my code Shankar tab. So we have the batch for CSC mains and IRMS and GATE and ESE also together. If you want, you can join that. Okay, I'm going to start with the signals and systems for this. Okay, this is our core electrical batch bhi hai. Okay, signals and system we are going to start on this particular course at 7 a.m. For 24, 25 aspirants, if anybody is interested in that, they can join that. Okay. So anytime you want to take an academy subscription, you can use our code Shankar. So thank you पर यूपीएससी एनी सब्सक्रिप्शन में आपको मैक्सिमम डिस्काउंट के लिए आप मेरा कोड यूज कर सकते हैं अभी तो ऑफर भी है यू कैन सेव अप टू 30% by using the code Shankar10 and join. So this exam is going to happen on this next Sunday also, that is 15th Jan. So don't miss this opportunity. You can get wonderful scholarships and also get a great experience to understand where you are committing the mistakes and get the real-time experience to get your ranking and immediate solutions so that you can rectify your mistakes before going for the original exam. So thank you very much, guys. ठीक है Okay, wait, no issue. Okay, according time is very important. Whichever is helpful, do it. But please study. That is what I want. Okay, आप लोग तो compulsory पढ़ना compulsory है भाई. कोई भी method पे you do it, it doesn't matter. ठीक है. Thank you. See you all. Bye bye. Okay, let's crack it. If you are a first timer, please don't do 1.5x, 2x, etc. Revision है तो 1.5, 2x में भी वीडियो देखो कोई दिक्कत ही नहीं है. ठीक है. Thank you. Love you all. Good night.